Section 9.2 refers to another type of transformation called symmetry. And this is going to be a transformation, and it's going to place the object directly onto itself. And we'll be doing this in an exploration. Now we have two types of these symmetries. One is reflection, and a reflection is when I have a line of symmetry. And I think of it as a fold line. And if I was to fold on this line, the figure would land on itself. So an example of that might be the letter A. If I draw a fold line or a line of symmetry, that part on the right lands on the part from the left. Now these lines of symmetry can be either vertical, horizontal, or at a slant. So again, the line might be vertical as I drew earlier, horizontal, or slanted. Another type of symmetry is, again, kind of a spin, a rotation. And that happens when I can turn the object. So we're going to spin it from 0 to less than 360 degrees. And again, it lands on itself. If I was to spin it 360 degrees, every object would have 360 degree symmetry. So we have to keep it less than 360. And we have a special type of rotation symmetry called a half turn, which is equal to 180 degrees, and that's called point symmetry. And again, we'll be looking at that in an exploration. We're going to skip patterns, and we're going to jump down to symmetry for 3D objects. A reflection. What we need to think about in 2D, in 2 dimensions, a reflection was done about a line. Well, when we go to 3D, that reflection now has to be a plane. It has to slice through instead of just be 2-dimensional. It's got to actually slice through, so it adds a dimension. So rotational symmetry, when we had it in 2D, it was a point. But when we go into 3D, this point then becomes a line. And we'll illustrate that. And this is something big for deeper later mathematics, is understanding this rotational symmetry about a line. Some other neat things with shapes and transformations is called a tessellation. A tessellation is when you just repeat the figure, so it's a repetition of some shape or figure. And when I repeat it, there are no gaps and no overlaps. So there's no space between these figures, and we'll be making some of these, and we'll figure out the big question of when and why shapes will shorten it to tile a plane. So if you think about regular tiles, a cube, a rectangle, or I want to say actually a square, will tile. We want to keep it in 2 dimensions. A tile in a bathroom that's square will tile or tessellate. Semi-regular means 2 or more regular polygons are used. 2 or more regular polygons. Now remember what a polygon is. It's got straight sides to it. Regular means they're all the same lengths, therefore their angles are all the same length as well.